Hello and good afternoon. How are you doing? Everybody tired? Ready to party? This session is going to be pretty interactive. If you have your laptop, you can fire it up and start working on the workshop. Typically, our workshops are all hands-on, nothing to pre-install. A couple of you asked me the question if I need to reinstall anything. If you fire up your laptop, you can start following along, or you can do it later, whatever works for you, okay? I know that there are no plug points here, so it's going to be a little hard to have a laptop running for about 2 hours. Feel free to do it later. I'll probably take about 45 minutes, to kind of go through the presentation, max, and then, let you guys kind of play with it, okay? Oh, and by the way, there was some confusion in the, room numbers. So if you're here for the bare metal one, you probably need to move one room over. Yeah, okay. And if there are anybody there, just send them over here. If they're looking for the Quarkus talk. But this is a talk on Quarkus and Cassandra, and the way I kind of put it is the way the Swiss scientist Nicholas Wirth talked about this about 50 years ago, probably even longer than, even before that. Basically, it's, programs is equal to algorithms plus data structures. That's basically what he said, right? Programs is equal to algorithms plus data structures. So the way I kind of look at it is Quarkus is great for reactive programming, and Cassandra is great for responsive data. So I kind of put the two together, and you have a pretty powerful equation. Okay, so we'll look at both Quarkus and Cassandra here. Typically in our workshops, we try to level set. We try to figure out how many of the attendees are new to our workshops and so on and so forth, right? So how many of you already are Quarkus? I have played around a little bit with Quarkus, played a little bit. Okay, how many of you would consider yourself an expert in Quarkus? Okay, so this is the perfect audience because actually this is a basic talk. I know there are other Quarkus talks, especially the one on Friday. I'll point you to that. So once you attend this, you get up to speed a little bit. There are several other talks that you can get a little bit more information. So if you have never or haven't done a lot of Quarkus, how many of you are kind of Java experts? Java experts, so okay, got to watch out for these three guys. Okay, but you three, one of you has played with Quarkus, but the others haven't, okay. One last question, how many of you have used or heard of Cassandra before? Apache Cassandra, used or heard, okay, that's kind of what I expected as well. So I'll do a very quick intro of Cassandra, and really the focus of this workshop originally was about the inner loop of development. And what I mean by the inner loop is, I come from the Cloud Foundry side of the world. I don't know if any of you used Cloud Foundry before, any of you? I know I said last question, but I lied, right? But essentially, the coolest thing about Cloud Foundry is you just do a CF push, and it's going to stand up your application. I jokingly refer to the fact that I got a lot of gray hair because I had to kind of worry about mundane things about development, like, what is the SSL endpoint? Why do I worry about certificates? How do I load balance them? All of that is automatically done for you, especially with Cloud Foundry. But with Kubernetes kind of taking over the world, right? You don't quite have the same, CF push there. But using Quarkus with Kubernetes, actually you can kind of get there. And I'll show, in today's workshop that you can pretty much get close, maybe not the same, right? Look at it yourself whenever you can, okay? So intro to Quarkus and Cassandra, again, if you are in the bare metal talk, that's happening in the next room. And this is the Quarkus and Cassandra talk. We can skip this. We have a whole crew, and in fact, I'm honored to have Mary here, who I'm meeting for the first time. I haven't seen her before. This is all the pandemic fun, right? So I'm really, really thrilled just to be in front of people, okay? No matter what I talk, I don't care, right? It's just so nice, and I really want to thank the organizers for doing a fantastic job. It just feels like things are back. I'm going to hold my, cross my fingers, cross my toes, everything, right? But hopefully, we'll all get back to where we were before. But the point again is, it takes a village to do anything like this, to change the way you do development and so on. And this is the village that is behind me. We do our workshops every week on Wednesday. Now we have cut it back to like once in 2 weeks. But these are all free. Feel free to attend. We have people from all over the world who attend. I'm sure there are quite a few people from Poland who attend. Quite a few people from Europe. Quite a few people from India. Quite a few people from US. And for myself, my name is Raghavan Srinivas. But I don't know why people have a tough time pronouncing my name. Okay, so I just go by Rags. Rags, not to riches, easiest way to remember me. And basically my undergrad was in mechanical engineering, and that's the reason why I like many of these workshops, or I like the workshops in general, is because that's the closest I can come to see things move in software engineering. It's kind of like, that's the only way, you feel the cause and effect relationship, right? I'm a big fan of distributed systems, and I really love to teach and communicate. But again, a very, very big fan of inner loop. The kind of things that you do over and over again, right? You compile things, you do something, then you push it, you profile it, you debug it, and then finally you stand it up to, send it to production. If we can speed up this inner loop, I think we can really get a lot of productivity gains. And that's kind of what I'm here for, okay? You can reach out to me on a variety of social platforms, right? And obviously I cannot make up my mind about which handle to use. So it's all a little bit different, but it's all kind of similar. I'm Rags on LinkedIn, Rags NS on, what is it, GitHub? Oh my God, why am I blanking out here? And Rags S on LinkedIn, okay? I also am, I come from the Kubernetes and Java side of the world. In fact, from the Java side of the world, I spoke at Devoxx Poland about 10 years back. Anybody been here before? And I don't think I've come back since then. But again, for those of you, who like this shirt, it looks, I think it's Krakow, right? Is that right? But, Dynatrace is giving this out. You can get it handmade. There are 3 or 4 designs. So I had my DataStax shirt on, but I decided I want my Krakow shirt on. So go ahead and get it. I think it's outside over there. All right. I did this with one of my partners in crime, as I call him, Eric D'Andrea. I don't think he's at the conference, but his colleague Daniel O is here at the conference. In fact, he also lives in Boston, and I bumped into him on the flight. Feel free to. I asked him to walk in if he can, so he may walk in at any point of time. And if he does, I'll introduce you all to him, and you can ask all the tough questions to him so that I can take the easy ones, right? But this is a book that he wrote, Eric D'Andrea wrote, Quarkus for Spring Developers. I'd be happy to, or he would be happy to send you some autographed copies, if you email him or whatever, okay? But this is all available, downloadable, free on the internet, okay? If you just go to Red Hat developer, whatever, right? You can download this book, okay? All right. So here's the agenda for today. I know it's already 10 minutes, but I think I'm doing okay. I feel like this is going to fall off. If it does, we'll figure it out. So the agenda is the intro. Then I'm going to do a little bit of NoSQL. Then a little bit of Cassandra, then a little bit of Quarkus, okay, and then really talk about microservices, Kubernetes, and how you can containerize easier with Quarkus. I mean, this is not the only answer. Obviously, there are other answers as well. And then we'll do some live coding. You will see me struggle a little bit with, with the demos and so on. So, it's always fun, right? And somebody else is struggling. But hopefully, most of the demos will work. In fact, I brushed them up only this afternoon, and everything seemed to be okay. But again, I don't want to jinx it too much. And then finally, I'll point you at some resources, okay? Any questions before I get started? No? Okay. Feel free to jump in anytime. If you have a question, just raise your hand and we'll figure it out. We're going to build a real super complicated app today, okay? It's the to-do app, pretty straightforward. As you can see, it's a to-do app, right? And basically what I do is I add my to-do into the to-do list, okay? So as you may expect, it's really great. It maps really well with the CRUD kind of model, right? Create, read, update, and delete. That's all you do with this, right? Pretty much that's it. So what we're going to do with Quarkus is kind of build a REST interface, and that's reactive, all of those nice things that, automatically comes with Quarkus, and we'll take a look at that. But today's challenge is going to just be building this to-do app. And actually, I've done this workshop a few times before, and most attendees are able to get through this. My suggestion would be, there is a whole bunch of kind of intro to Quarkus material in the beginning, but I guess what you can do is just do the test, make sure everything is working, and I'll point you at the repository, and then what you can do is you can go straight to containerization, okay? So basically you can containerize the app fairly easily and run it in, in any Kubernetes cluster that you want. There are two recommendations that we provide in this particular talk, or in this particular workshop. One is you can run it in a service called OKTito. Any of you used OKTito before? No? That's pretty cool. It's basically like within Google, and they separate it into namespaces. We don't need to worry about any of those. And then, if you don't like OKTito, you can use another, this thing called Lens. Lens provided a thing called dev spaces. So basically, it's your cluster on the cloud. So you can use either of the two, depending on your convenience. I know that I said last question again, but how many of you have used Kubernetes before and used the kubectl command? kubectl, okay, that's great. Because I'm going to be using I'm going to be doing a little bit of that, okay? So let's accept the challenge and jump straight in. No big deal about NoSQL. It turns out I was there at San Francisco at the same time. This was around June 11th, like what, 13 years back? They wanted to come up with some fancy hashtag for something that is not Oracle. Basically, that's what it was, right? They didn't want something that was relational. By the way, nobody from Oracle here, right? No offense meant for anybody. But the idea was that everything was relational, everything was tied very closely with schema, and it was not really suitable for horizontal scaling. And what I mean by horizontal scaling is, the traditional pets versus cattle theory, right? Where you treat your machines like, or your infrastructure like cattle, right? So if one goes, no problem, you move on to the next one, right? Whereas the traditional model was really more about pet. If you think about Oracle is the pet approach, and this is the cattle approach, okay? Either of them kind of works, right? But in general, if you want to achieve linear scaling over thousands and thousands and maybe even tens of thousands of nodes, which is what really Kubernetes is all about, right? It's really about horizontal scaling. You cannot easily do that with a relational database, right? Like Oracle. It's really about horizontal scaling, and sometimes this is now referred to as not only SQL, new SQL, but you get the idea. It's just not the traditional SQL model. So I don't want to spend too much time on the NoSQL, because there are plenty of workshops you can go take a look, and I'll point you to that. But essentially, and again, a lot of the lines are diminishing. There is a lot of overlap between the two, if you will. And there is even talk about providing transactions on Cassandra, okay? So the worlds are kind of merging. But at this point, really, what it is, it's really about easy to scale. It's really about horizontal scaling. And you know, the traditional relational model does not scale because you can go up, and up, you know, to a degree, and after that it's going to keel and fall off, right? You know, I mean, there's only a limit. There's only a certain limit that you can hit. But the idea behind the NoSQL, again, is that you distribute your data. You know, for those of you who are Java, and all of you are, right, my simplest analogy is that it's like a distributed hash table, okay? I don't care about where my data is. You know, it's going to be hashed into a particular node, right? But if I were to do all of this myself, right, what happens if this particular node goes away, right? What happens if I add more nodes? All of that is handled by the platform, okay? It has a consistent hashing algorithm. It takes care of distributing your data in such a way that it's resilient, so even if one node fails, it's able to service the request from another node and all that, you know, all that beautiful things that you've heard of, right? All of that is taken care of. And let's see, but there is no such thing as a free lunch, right? There is no silver bullet in software. We know that, right? The moment you have all of this, there is something else that creeps in. And this is enunciated very well by a scientist called Brewer. I believe he works for Stanford now. But essentially, it's called the Brewer's conjecture or the CAP theorem. How many of you heard of this? If you heard of this, I'll just skip it. Yeah? Okay, few. But basically, when you have a distributed system, and you have these three properties, right? Consistency, availability, and partition tolerance. You can pick only two of them, you know, two of the three in a typical failure scenario, okay? So hopefully I'm trying to explain this correctly. Essentially, when everything is ticking fine, no problem, right? Everything is fine. You can have consistency, you can have availability, you can have partition tolerance, no big deal. The moment there is a failure, you have to sacrifice one of these, okay? And that's inevitable, right? So there is different degrees of consistency that different NoSQL databases provide. So some of them might say, I want strong consistency, in which case I have to give up one of the two, availability or partition tolerance. And turns out giving up partition tolerance is a real sin, because even my grandmother can figure out that the data is not consistent. You know, on the other hand, if you give up on availability, it's probably okay. If you give up on consistency, it's probably okay, because, you know, if my name is not on top of the leaderboard for 20 seconds, it's not the end of the world, right? Of course, some of you might disagree with that, right? But the point I'm trying to make is, it's probably even okay if my account balance does not reflect, you know, the exact thing that happened about 20 milliseconds ago. It's probably okay, right? You can deal with it, because you may not need a transaction, you know, immediately. But so in terms of like ACID, right? Many of the NoSQL databases don't do that. But again, you know, like I'm saying, like I said before, these things are changing. You know, in Cassandra, you can tune your degree of consistency. Okay, there's eventual consistency and there is strong consistency. You can kind of go between all of them and all that. And typically the way, you know, the NoSQL databases, there are really hundreds of databases, NoSQL databases, okay? And they map into either like a CA system, a CP system, or a AP system, okay? Cassandra is particularly, you know, is very religious about keeping partition tolerance. So in other words, we are not going to sacrifice partition tolerance, but it's probably okay to give up on consistency or availability. And depending on what consistency you pick, then it may not be available for the time the system is down. So you may have to work around that and so on. The applications have to work around it. So that's more than enough about NoSQL that you need to know, okay? So the nice thing about Cassandra, again, is that it's no single point of failure, and it scales for writes and reads. Very linearly scalable. But like I said before, there needs to be some kind of partitioning that has to happen, right? If you go into the data modeling for Cassandra, you know, we can talk about hours on the data modeling. There's something called as a partition key. Okay, and the partition key is what allows the data to be distributed across the, you know, cluster. Okay, so that has to be done. But the point is that, again, Again, we have a saying in DataStax, who we maintain Cassandra. There are a lot of other companies which also maintain Cassandra, but we are probably like 80, 90% maintainers of Cassandra. And essentially, we have a saying that it's, friends don't let friends shard. Because sharding is hard. It's not something that you want to do. So in other words, I could build my NoSQL system myself, but the point is, you get into all kinds of systems like all kinds of situations where what happens if the partition fails? What happens if all the data goes into one partition called the hot partition? How do you deal with that? How do you deal with nodes coming back and redistributing the data and all that? And all of that, like I said, is handled by the platform. Is Cassandra AP or CP? You probably know the answer to this already, right? Lot of different companies use this. Really, where scale is necessary. And nowadays, even in internal applications, scale is important, right? Because somehow or for whatever reason, everybody hits it at the same time, right? The moment you ask your employees to sign up for the healthcare starting next year, everybody hits it in October or whatever that is. This happens typically in the US, and I'm sure there's those same cycles that happen in Europe as well. But I've talked to many of these customers or some of these customers, and many of them say that their Apache Cassandra nodes have been running for 8 years. And I haven't had to reboot the node. I find it hard to believe it, but I hope they're upgrading their Cassandra version. I'm sure they are, okay? But one of the cool things about this is, again, it can be on any cloud. In fact, I don't even care which cloud it is. I also do a talk on kind of distributing across different clouds, and I have a Cassandra cluster just for kicks. Whether you do it in production or not, I've installed a Cassandra cluster across GKE and EKS. Okay, GKE is the Google Cloud, and EKS is the Amazon, what is it called? Elastic Kubernetes Service, right? So those two. And the cool thing about that is we have a new thing called a Cassandra operator. Cassandra operator kind of does the multi-cloud install. And the way it does the multi-cloud install, I've installed it through Azure. So I've used AKS, GKE, and EKS. Pretty cool. And I'm going to be demoing it next week at KCD Berlin. Any of you from Berlin by any chance? Yeah? So if you're not there, or if you want a reason to be in Berlin, you can come to my talk. But if you don't want to install any of that yourself, we have AstroDB, and I know Mary talked about this in her session, is that this is database as a service, okay? So what we do is, we provide a $25 credit, which is actually pretty good for running production workloads, believe it or not, okay? And the cool thing, since many of us, many of the developers, many of you actually attend the workshop, everybody says, the coolest thing is I don't need to put a credit card. All that you need to do is put in your email, and you get $25 US dollars free. Right now we have mainly on GKE, but if you really want to install it on AKS or EKS, you can do that as well. If you put in a credit card, money always talks, right? You can install it wherever you want. Okay, but basically it's a database as a service. It's based on open source Apache Cassandra. And like I said, $25 US dollars credit, and it's front-ended, from a developer perspective, I don't really care about database as a service, as long as the service is there, right? It's front-ended by what is called a Stargate, which is a unifying API, very cool. It provides you with all these different options, okay? You can use SQL, you can use REST, you can use GraphQL, you can use gRPC, and so on and so forth, okay? All of these is unified in one. Because as a developer, I want different options, right? I might just be fine with SQL. SQL is referred to as Cassandra Query Language, which is similar to SQL, right? Just a play on that. Now I talked about installing it on GKE and EKS and so on. How is it done? Using a project called Cassandra, okay, which is kind of a cool name, I think, right? It's Kubernetes and Cassandra, or Cassandra running on Kubernetes. So you can install it yourself. And how the heck do I install it? I did not put it in there, but basically it's just a very simple Helm install Cassandra, okay? And I have some workshops that go through that as well. So moving on, data is one side. Now let's look at programs, right, or algorithms, right? And this is where Quarkus comes in. So Java, as you know, was designed for a different era, right? A lot of us had this language envy, right? We wanted that cool, hot reloading feature that Node.js provided, right? You make some change here and automatically reflected over there, right? As simple as that. Why couldn't it have been in Java, right? But the idea for Java is that it took a lot of what am I blanking out on? It took a lot of the class loading, the class, checking, security validation, and all that was done at the runtime, right? But there are things that you can do at compile time, and you can obviate, some of the time that's taken at runtime, and make it a lot more efficient to be used in containers. And that's really what we're going to see today. So a typical Java framework, like I said, there is a lot of things that happen at runtime. Like, for example, load the config file, do the class path scanning of the annotated classes and so on, build a model of the world, start the thread pool, and so on and so forth, right? Really, at build time, the only penalty you take is kind of packaging it up and so on, right? And getting the classes ready and so on. What Quarkus does is it kind of flips this around. So let's take the penalty as much as possible in the build time. In fact, today, if you follow the exercises, you will be able to build a native application. And what does a native application mean? A native application means that something that's built for the operating system. You don't need any interpreter. You don't need the JVM. Remember JNI and all that cool stuff, right? Which was not cool at that time, but that's kind of coming back now, right? Fashions come back, right? That's kind of how it works. But the idea is that, again, if I'm running it in a container, why don't I take the penalty at the build time, right? And then make the runtime super fast, right? And you will see if you generate a native image, it takes about 5 minutes to generate the native image. But that's probably okay, right? Because what you're going to do is you're going to do all the testing, the inner loop, make sure that everything is working, and only then you're going to push the native image, right? So which is probably okay. So it enables native compilation, which is kind of neat. So you don't even need the JVM, and it will compile it for that particular operating system. I've tested it on Mac, I've tested it on Linux, okay, and you'll see that. But the cool thing is, it's still Java. It's not a paradigm change. You don't have to leap into a new way of doing development. It's not. You can still use the same IDEs that you're comfortable with. If you want to use VI and Emacs, that's fine too. It doesn't matter, right? You can do the same tools, the same culture that you're used to, but with a slight difference. Okay, and that's the nice thing about. But what does it do? It does a whole lot to the inner loop. Okay, it's really about developer productivity and kind of trying to streamline your inner loop. Kind of trying to get to the Cloud Foundry model as closely as possible as you can. Okay, and we'll see that. Okay, InfoQ ran a series on Kubernetes native with Java. Okay, and Quarkus was one of them. There are other ones too. Spring is doing something similar, and then there's Graal. There are other Helidon. There are so many other frameworks as well. But definitely Quarkus was one of the early adopters here. So microservices, you might have seen this. I'm not even going to spend time on this. But essentially, distributed systems kind of morph itself every 10 years, right? You started off with monoliths, and then somewhere in there was, I don't even want to mention this, but I'm going to mention this anyway and give out my age. Any of you remember Corba? Nobody remembers Corba? I know all of you are young, but I didn't think you were, you're not even heard of Corba. Yeah, maybe it's that old. But Corba had something called as IAOP, or I don't even know what IAOP stands for. Somebody can tell me later. But essentially what it did was it would generate the stubs and skeletons to be able to connect a Java program to maybe like, I don't know, like a Node or Python or anything like that. So the philosophy was it would generate the stubs and skeletons in such a way that you were able to connect the two together. And that was really how RPC was done. But today we know that we have evolved from there, right? And the idea is that we provide most of our services through REST-based APIs or gRPC APIs or so on, right? And that's kind of how the microservices model works. Do one thing and do one thing right? And then provide a service that essentially not only can internal developers use, but also external developers are going to use the same thing as well. Has everything, and everything is based on like the CRUD interface. And again, you want the data to be super fast as well, not just the program. And that's where I think NoSQL is going to help you, and Cassandra is going to help you. Okay. So obviously, microservices have a lot of advantages and a lot of disadvantages, right? Not necessarily disadvantages, but there are certain things you need to be aware of before you go all into microservices, right? Some of the things that become a little harder is the complexity, right? How do you kind of keep track of all these different services? How do you make sure that failure scenarios? How do you deal with it? And all of those are, not covered in today's talk, okay? But something to keep in the back of your mind, okay? But the advantage is that, you can scale things independently off of each other, right? Gone are those days. The waterfall model, I remember working on my first project where we released every 6 months, right? And then when we moved to every 3 months, it was like it was the coolest thing that we did, right? But every 3 months doesn't cut it, right? You have to do at least, 3 times a minute. That's kind of how we have gotten. The world has moved to, and there is no way you can do that with a monolith. You have to do it, with microservices. What we have done with Quarkus is we have a native Quarkus Cassandra extension, and you will see that today it has Cassandra driver support. I'm not going to talk too much about drivers because this is not a driver talk. And then it basically supports Cassandra in different forms, whether it's local, whether it's running in a Docker container, whether it's running in Astra, which is our database as a service, all of those, okay? And there are different configurations that are possible, okay? In the first case, you're connecting to Astra, and in this case, you're providing the username and password. You can also do it locally as well. So there are different models for that. So let me. You'll see the code yourself, okay? But it basically supports all the mutiny types and all that. So let's go to the live coding part, and let me see how I'm doing with respect to time. I was exactly thinking about half an hour, so I'm doing reasonably okay. So what I'll do after this is, point you. I'll walk through the demo, okay, and then I will leave it up to you guys. If you want to play around, I will hang out as long as you're you're interested. But if you want to do it later, that's fine too. The first thing that you may want to do in the meantime, if anybody wants to play, really do this, is get an Astra token, okay? And all of those are outlined, and I'll point you at where it is, okay, in just a second. So how do I do this? List all tasks, create a new task, mark a task as completed, delete a task. So CRUD, right? As simple as that. Create, read, update, delete, okay? And turns out, I never knew this before. To-do has a complete ecosystem around it, okay? There are ways in which you can validate your spec. There are ways in which you can connect to a backend that you have never heard of. And I'll guarantee you, there will be something that you have never heard of. So it has a complete ecosystem, and we'll take a look at that, okay? This is the data model. Don't need to spend too much time on this. It probably is very obvious. User ID is the key. And then within user ID, this is something that Cassandra provides. You can have a key that you can sort on either on the ascending or descending order and so on, okay? So the service has find to-dos, create to-do, and I'll walk through the code a little bit, delete to-do, update to-do, and so on. And all of those are based on REST API. And you can get the REST specifications by just doing the /q/dev. I don't know if any of you have seen this, but we'll walk through all of this in a second, okay? So this is the to-do MVC framework, okay? And let me show you this. It's a pretty extensive. I'm a man of many tabs, so don't laugh at me. All right. So this is AngularJS example. So if you just do examples, you'll see a lot of different examples. Or maybe not. So to do mvc.com maybe. Okay, and you'll see a lot of examples here. Okay, so AngularJS is just one of them. Okay, and then like I said, let me see. As I'm thumbing through that, I'm sure you're noticing some of those that you have probably never heard of, right? But it's Aurelia. I have no idea what that is, right? But anybody know Aurelia? No? Okay. So this is the cool thing that I like, right? It's not so much to say that, I have nothing to do with this, right? It's the ecosystem that you can take advantage of. Okay. So let me go back to the presentation. Okay, that is todomvc.com. And there is a backend, which is also todobackend.com. Okay, hopefully I get that right. So this is the to-do backend. So you have the front end and you have the back end, right? So the front end is the GUI and the back end is really for validating this, and these are built with this. There is a Heroku application. There is a whole bunch of these like Lyft. You can kind of play around with this. The point is that it's an ecosystem that I never knew existed. Okay, so kind of cool. All right, so let's go back to the slideshow. You can also get the REST API. I think if you can /q/open-API. I don't know if you guys can see that. And I'll show this in action as well. Hopefully it's going to work, okay? But from our perspective, it's pretty straightforward. What we are doing is we are creating this, at least most of this, right? Essentially, we have a very simple front end, okay, which basically is, you can take a look at that later. And then we create a REST service, which essentially does create, read, update, and delete, right? And then you have the Astra DB service that backend connects to, and that is where, you can start by creating a token and connecting to it. And all of this will be done today. Pretty straightforward, but it kind of illustrates a typical application as well, because you're kind of doing everything, in the application. Okay. You can use Lens or you can use kubectl. It doesn't really matter. Lens is like, if you don't really want to use kubectl, you want a higher abstraction, you can use that. And these are what Lens gave this to me. In fact, we did a talk last week at Open Infra in Berlin, which went through basically the same talk, Quarkus and Cassandra, but essentially using Lens. So you have two options. You can either use Lens or you can use kubectl if you want, okay? But if you don't want to use, if you don't want to play around with this today, you can always jump into our workshops, which happen every Wednesday, every other Wednesday actually, around 11 a.m. Eastern, which is like what? 11 plus 6, 17. So 1700 hours here in Central Europe, okay? Except a few weeks in the year, 2 weeks in the year, I think we are off by 1 hour or something. In any case, 11 a.m. Eastern, okay? You can complete the workshop and labs, and actually you can get some cool badges, okay? I've been told that salaries have doubled by just adding some of these badges, okay? But don't quote me on that, okay? But it's really cool. A lot of people are very proud to put this on LinkedIn because we actually grade your homework. We give you some homework, not very tough, okay? But we grade it as well. So if you're interested in badges, feel free to do that, okay? Quarkus for Spring developers that I already showed you. Okay, and then Daniel O has written this. So if you happen to see him at the Red Hat booth or somewhere, you can ask him some questions about this. With that said, let me jump into the actual coding. And the way you're going to start is you're going to start with this github.com/datastax devs workshop intro to Cassandra. Okay, do you guys see this? Let me put this up. Okay, and I will get started on that. Okay, so this is where it is. Okay, and let me put this up here. I don't think you guys can see it, right? So what am I doing? All right, so let's look at this font size. Make it big. Too big. Okay, this is much better. Okay, you go to DataStax devs, and if you look for Quarkus, you should be able to find it. Okay, so let's start with that. All of the information is in there. Okay, I really don't need to do anything other than just follow the instructions top to bottom. Okay, so everything is in here. Intro to what do you need? What is the objective? Blah 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 blah. Okay, there are alternate learning paths in the workshop. Okay, if you're just focused on containers, you can skip exercises 7, 8, and 9. Okay, but if you want to know the whole thing about Quarkus, you can do that as well. So the table of contents, this is kind of how it walks you through. You create the AstroDB instance. Okay, you create a token, launch Gitpod. Okay, I'm never going to say again that I'm not. This is my last question because I keep asking questions. How many of you used Gitpod before? Anybody use Gitpod? Nobody use Gitpod? It's the coolest thing since sliced bread, really, I tell you. Because what it is Visual Studio Code in the cloud, okay? VS Code in the cloud, and automatically it sets up the environment for you. And some of you ask me, do I need to do any pre-install before I come for the workshop? And the answer is no, because what happens is VS Code or Gitpod in this case does this automatically for you. Okay, and you will see this in a second. Okay, this is kind of how it looks. Let me give you a peek on this. Okay, the moment you open the link, you will get something like this. All that it needs is a GitHub login. Okay, and most of you, I'm sure, have GitHub login. And with the GitHub login, you can log in. If you don't have GitHub, I think there are alternates as well, like GitLab and so on. Okay, but it's going to bring this up. Okay, but in the meantime, let me go back. Okay, look at what we're doing. We're going to create the Astro token. We launch a Gitpod. We set up our application. Really no setup, because what we do is we copy the, remember the secret that we had to provide and the ID and the secret. We do that. And then what we do is we run the unit test, make sure it works. Unfortunately, we don't spend too much time on testing here, although Quarkus is a fantastic framework for testing. Okay, and then you do the debugging, packaging, containerizing, and so on. My suggestion is skip 7, 8, and 9 for this workshop, because you don't have time. If you want to do it, you can do it, and go straight to containerizing, native image, no homework. Okay, but if you want to do homework, you can definitely do that as well. Okay. So let me just follow along with this. Okay, and that's what I do. Let me put up this link again once more. github.com/datastaxdevs. /workshop intro Quarkus Cassandra. Just go to DataStax devs and look for Quarkus, and you should be able to find it. Okay, and look for the workshop thing. Okay. All right. So let me go back here. Follow along. You create a database name called workshops. Okay, and you create a key space name called to-do list. We often get a question, what the heck is a key space name? A key space name is not a big deal. It's just a logical grouping of related tables for a particular solution, okay? So all of the to-do tables, and there is only one of them, right, is in this key space called to-do list. You can think of an e-commerce application or something which may have a lot more tables, so you kind of put them in all into this same key space. You create the database, and it'll become active when the database is ready. So let me know when you guys are already created a database. I know a couple of you are following along. But if you have any trouble, let me know as well. I've already done this, so I'm going to skip this step. But essentially, there is a walkthrough as well, which kind of walks through how this does this. Okay, so where the heck is the walkthrough? Here's the walkthrough. Okay, so you create a database. Essentially, pretty straightforward. You log in, and I think somewhere here there's a create database, and that's pretty much it. You put the database name and the key space name, okay, and you're good to go. Okay, and you specify the region. Okay, we suggest that you use GKE. Anybody trying on your mobile phones? It may be a little hard to do it, but I've never tried it actually. May work. I have no idea. Okay. So once you've done that, you have to create an Astro token. The point of the Astro token is that, actually, let me show that in action. Okay. So creation of a token, Astra. You can go to Astra. Okay, sign in. Okay, and then creation of a token, you just go to the organization. All of this is specified. Organization settings. Okay, and then token management. And select a role, we just make it very broad. Probably not a good idea, database administrator, but that's fine, right? And then say generate a token. Okay, it will generate a token with a client ID and a client secret. Okay, so what we need is the client ID, the client secret, and then we also need a zip file, to be able to connect to that, for authentication purposes. All of this is outlined in the steps. Okay, so we get the client ID, the client secret. The only thing that we suggest is that if you navigate away from this page, you're going to lose this. So a good idea to copy the client ID and the client secret somewhere. Okay, I usually have it in my a wonderful, safe Excel spreadsheet. Okay, not a good idea, but this is just for illustration purposes, right? Okay. So when you launch Gitpod, this is what shows up. Where the heck did Gitpod go? Oh, there it is. Okay, so here it is. So initially, when you launch it, it's going to do a whole bunch of stuff, and it's going to build the image and all that. So as you probably know, Maven downloads the entire world, right? So it downloads. It takes a little bit of time, and then you're up and running. Okay. So if you do echo Java home, if only I can spell it, you can see here that it's Java current. So essentially, it's basically whatever SDK man is using, and SDK list Java, is that what it is? And you can see here that I have a whole bunch of them installed, and this is my default VM, Graal VM. Okay. So you should be able to see all that. All right. All of that is automatically done for you. You don't have to do anything really. Okay. All right. So moving on, let's do the next step. I have done this, and I've launched my Gitpod. I already did. If you just click on this link, right? I'm not going to I'm just going to bring that up, open link in new window, okay? This is kind of what you're going to see, okay? It's saying that this is already, you have a running space with the same context. Do you want to switch to that context or do you want to open a new workspace, okay? I could open a new workspace if I want, which will essentially start the whole thing from scratch, right? But, I don't really care because I've already done it. You're probably going to do that, okay? So you launch that, okay, and it uses 8080 and port 5005 and all that, but we don't care. Gitpod uses 3 windows, primarily. I mean, you can create more as well. But essentially, this is your kind of Explorer window, if you will, right? This is what you see in VS Code Explorer, right? So for example, if I want to walk through the source, right, I'm going to dig through source, main, Java, and let's see. Let's look at API. Okay, and here's my to-do Java, right? And you will see here, right, I have my to-do and so on and so forth. Okay, so if you want to take a look at the rest, I have my to-do resource.java, and basically I think it'll show you, what are all the endpoints that are available, right? So to-do, list ID, delete. So basically it maps to the CRUD that you're used to, okay? So, all right. So this is the Explorer window. This is kind of the code window or whatever you want to call it. And this is my command window. Okay, this is where I issue all my commands, right? And you'll be doing most of this in the command window, all right? Okay. So know your public URL, this is one of the cool things about Gitpod. Instead of a local host, it will provide you with a public URL. Okay, so this is my URL where my application is going to start. Okay, so if I look at this application, okay, it's probably not going to be running right now because nothing is running, right? I haven't run the application, but I'll run it in a second. Okay, and keep going, right? So it might ask you for allowing and all that, but let's not worry about all that. The first thing you're going to do is you're going to open the application properties, right? So you're going to open this, okay, and you're going to cut and paste the client ID, username, and the password, okay? So it's provided here, Astra username, Astra password. So how you're going to get this? This is from the token that we got before, okay? So the username and the password is what you're going to use. And then I have dropped this zip file, which is the secure connect workshops.zip, okay? And this has to be roughly about 12K. You'll see here it's about 12261, whatever. Oh, by the way, is the font too small? I should have asked this before. Too small? Okay, so let me see if I can improve it a little bit. A little bit better? A little better, right? Not a whole lot better. Okay, let me know, when. Okay, so let me actually. It's a lot easier when you're doing these workshops virtually. There are some advantages for virtual workshop, right? The fonts are a little bit better. They show up a little bit better, strangely. Okay. So now that I've done it, again, I just follow along, right? I look at this. I've set up the application properties. I set up the Astra username and the Astra password. I'm all set. I downloaded the zip file and I've dropped it into this particular directory. I've verified that it's about 12K and I'm good to do. So the first thing I do is run my unit test, okay? Thanks for test-driven development, right? I've gotten into so many issues and I've never been able to debug, but if I had run the test first, it would have told me what was wrong, right? So let me see. First test is the test, right? Let's see if this works. And again, when you are invoking this the first time around, it'll download a whole lot of the world. Maven is known for that, right? But eventually, the application should start up. All right. So it's running this, and essentially what it's doing is it's connecting to Astra and creating the table if required. If the table is already created, it's just not going to do anything with it. Okay? Very simple test. But at least it verifies that my client ID, my client secret, and the Secure Connect bundle that I use for Astra is all set up properly. If this doesn't work, there is no point in proceeding, okay? So let me know once you have downloaded the tokens, the client ID, the client secret, and the zip file and put it in Git pod and ran the test. You can do this anytime you want after that, okay? Those are kind of the steps that you will have to complete, okay? All right, so moving on, just following along. That's all I do. I do exactly the same that you would probably do, which is, cut and paste from here, right? And basically this shows that the table got created, okay? So if I run this test and grep table, okay, I will see that the table created is true or something like that, okay? Hopefully it'll come back. So basically I'm running the same test. Come on. So basically it shows the table got created, okay? Pretty straightforward. Okay, so once the table is created, now I'm good to run the other tests, okay, or proceed with the workshop. So, you can echo this graalvm home and hopefully, did we do this already? No, I don't think we did. Okay, echo graalvm home. Okay, you can see it's current, whatever, right? And then, oops, let's get rid of this. I don't need that. Okay. And now what I can do is I can run Quarkus in dev mode, which is very cool, okay? So now I'm ready to run it. So let's see what happens here. So unfortunately, I'm doing a lot of skip tests. Like I said, the strength of the platform is in the testing, but I don't think I need to do anything with that, okay? So it's saying 5005 is being used, and 8080 is also being used, which is fine, okay? So now if I go back to my to-dos, there it is, running. Okay, there's my Astra to-do, okay? So, it's not good. I don't know what's going on here. Like I said, I jinxed it. Okay. Okay, I don't know what's going on. Okay. Speak at Devoxx Poland. Very simple, right? And then prepare for KCD Berlin. All right, that's good enough. Okay, and then I can knock them off. So if I'm speaking at Devoxx, I'm done. So it's done, right? Very simple to do app. All right. So now what we can see is some of the power of the platform. And basically what this does is, you can do some pretty sophisticated things. Okay, so you can do what is referred to as development mode. Sometimes this is kind of flaky. So let me take a look at that. All right, let's not worry about this. I'm just going to add /q/dev to this. And this is the dev endpoint. Okay? So this is the cool part of the application. And you can kind of look at this config editor. Okay, and you can see here what are the passwords, what is the Astra username, what is the eager init, and so on and so forth. Okay, so it gives you a whole lot of information on the application, and it does actually hot reload. So if you change some of these properties, those are reflected in real time. And to see hot reloading, okay, we will see this in action actually. Okay, so what we're going to do is, so we've connected to the application. Now let's try to do the the hot reload. Okay, so here's my application, right? So let me take a look at the application itself, which is, let's not worry about this because, so you can see here there's a fork me on GitHub, right? What I'm going to do is I'm going to change it to fork me today on GitHub, okay? So to do that, I think what I have to do here is I should go into Java resources, source main Java resources, and I'm going to make the change, okay? So let me go back here, source main Java resources, metainf, and index.html, right? This is a very simple example. You can do something a little bit more complicated, okay? So here's my data ribbon, okay? I'm going to change it to fork me at Devoxx Poland on GitHub, okay? And the nice thing is, this is hot reloaded, okay? So if I go back to my screen, okay, and if I look at this, hopefully it should, so you see that? Cool thing about Java, it's like, this was there in many of the other languages, but this hot reloading happened just, without me having to do anything, right? And not only, this was a very simple index.html change, but you can also change the Java code as well and make it happen, okay? Which is very cool. All right. So if we move on to this, so we saw the hot reloading part. You can take a look at the metrics. You can take a look at the Swagger API. You can do a whole bunch of stuff like that, okay? So let me do again /q/dev/Swagger UI, I believe, if I'm not mistaken. Yeah? Okay, let's go through this qdev. So here, I believe there is somewhere in there the Swagger UI. So this also gives you the endpoints that are available, okay? So basically, here's my get, post, and delete, right? So if I want to delete, I can try it out here myself. If I just give the ID and the list ID, you can do all this, like a typical Swagger console, okay? So you can do all that. You can take a look at that. Quarkus metrics. There is a Quarkus Smart Dispatch as well, and you can take a look at that as well. And then finally, there's debugging. Okay. So let's look at debugging, which is very, very cool, especially with a IDE on the web, right? So let's see if this works. Okay. So what I need to do is set a breakpoint, right? Let's open this. Let me go set a breakpoint in there, okay? So let me stop this for a second. All right, and I'm going to open the SQL service, astroservice.java, okay? And I'm going to insert it at line 60 or something like that. Delete to-dos. No, I don't want to do it on delete to-dos. Where did I want to do it? Lines might have changed, but you get the idea. Line 52? Okay, something like that. So let me set it. Get table space name. Is this override? Oh, right here. Find to do, get to dos. I don't think it matters. Let me try somewhere. Delete to do, complete to do. Okay. So there are different methods here, that you can take a look at this as well, and you can let me set on the override. Let's set it here and let's see what happens. Okay. So now let's run this, and you can kind of look at this as well. Maybe on Quarkus dev. And we're going to skip tests. Okay, that's good. 5005 is the standard, browser port. Skip all that. Okay. And let's run the application. Okay. So let's run it and see if it works. I'm not going to spend too much time if it doesn't. Okay. So let's see. Okay. So I set the breakpoint in the wrong place, I think. Let me see an update. But you get the idea of what to do here, right? Let me try once more and then we'll give up. I think I had to set it in the update, which is where? Delete, complete to do, set to do, find to do by ID, get to do's. Where is the update? I will take a look at this. 54. All right, let's do this. Let's try here. Okay, so let's set a breakpoint there, and let's restart again. Okay. All right. Application up and running. Okay, and now hopefully it should set it up in the delete. Okay, so let's go ahead and delete this because I don't want it, right? And it did it. Okay, so I'm not quite sure what's going on with the debugging. I probably have missed a step somewhere or the other. What did I do wrong? I did set it up. But let me know what I went wrong. I'll try to figure it out later. Okay. So, but in any case, these are optional, right? Because these are not, critical for containerization part of it. Okay. And you can kind of take a look at. Oh, I know what I did wrong. I'm just running it in. Oh my God, it's been a while. So my apologies. Basically, what I have to do is. Let's do this. Okay, so I have to start debug. So this is the debug mode, and now you'll see the call stack and all that, which is kind of cool. Okay, so now let me see if this. Okay. Sorry? Right. Let's try the deletion, yeah. But you get the idea, right? I don't want to spend too much time on this, like I said. Let's give it one more shot, and then if it doesn't work, we are debugging it, right? So terminal, get rid of this. Okay, and let me start this again. Maybe it doesn't require the start. Okay. One more shot. If it doesn't work, I'll leave it up as an exercise for the attendee. Okay. Looks good so far. And run this. Oh, did I do that already? Okay. So now I'm running in debug mode. Okay, and I go back and run this. Okay. So let's see what happens now when I delete it, right? Yeah, it's deleting. Not quite sure what's going on. I'll take a look at it later. Okay, but I think I'm missing some step here that is critical here. Okay, but you get the idea. It's pretty straightforward to to do this. And once you use the debugging, essentially what it'll do is it'll have the the breakpoints. You can do the usual things that you do with this. Now the most important part of the workshop is the containerization. We use something called as a Jib plugin. Okay, Jib is a Google plugin, very cool. And essentially what it does is, remember we have to ship the Secure Connect bundle, right? And the only way we can ship the Secure Connect bundle is when we are packing it with the container. So what we're going to do here is we are doing exactly that. Okay, we are creating a thing called source main Jib subdirectory, and in there we copy the Secure Connect bundle, okay, which is the Secure Connect workshops.zip. So again, what we're going to do is do exactly the same. Okay, I'm going to quit out of that. Okay, I'm going to copy it. Okay, and then I can generate my container image. Okay, so let's make sure that it's all cleaned up. So Docker ls, right? Yeah, what is it? Docker images. I'm losing it. Okay, so I'm going to get rid of these two, the Quarkus Cassandra, so that we can start from scratch. RMI colon 0.01. Make sure it's gone. And git pod. Make sure it's gone. Okay. And now follow along with the instructions, right? This is the containerization part. All right. So to containerize that, what we're going to do is we're going to build this image. Okay. So let's go ahead and build the image. Very straightforward. It does everything for you. Okay, and that's the nice thing about Quarkus. You don't have to generate Docker file, nothing, right? It just does that for you. It uses the build packs, the cloud native build packs. Okay, if those of you are interested in kind of looking at that. And it should be good to go in a little bit. Okay. So now if I do a Docker images, you should see that it just generated an image, git pod Quarkus Cassandra, about 27 seconds ago, right? Or 22 seconds ago. So if I want to run it, how do I run it? Again, everything is packaged up here. I can just run it here, okay? And so notice here, this application is no longer running, right? Because I took it down. Okay, so the port is not running. So if I run it now as a Docker run, it should run. And I don't care about that, okay? And this is running my Docker image, okay? Is that clear? Different ways of running the same application. So it's really running my Docker image here, okay? So I can kill that. So what I'm going to do is I'm going to kill it, right? Because I don't want Docker. I really want to package it as Kubernetes, right? Because that's the way all the cool things are done, right? So to do that, I have to do a bunch of things. I have to Docker login, and I have to push the image and all that, right? So let's do all that. Docker login. I've done all this before, so it doesn't matter, but still I'm going to do it again. And I'll put in my, and I'm good to go. Except that I'm not good to go. Okay, so login succeeded, and that's good. So now I just want to verify my Docker ID. Okay, all of this again, it's in the repository. All that I need to do is cut and paste it, right? And my Docker login ID that will be used is ragsns. Okay, everybody see that? All right. And then I build my container image. I'm going to skip this. I'm going to add this. All this is done. You can take you can look through all of that, and I'm just going to directly push it to my public repository. Okay, and you'll see all that, here. Okay, so let me clear this up, and let me see if I can move this a little bit. Okay, maybe increase the font a little bit. Okay, and now what it's doing is it's pushing the image using this Docker login ID. Okay, image group, Docker login ID, and so on. Okay, and you will see here somewhere here it pushed it. And if I go back to my Docker Docker Hub, right? Docker.com. And let me sign in. You should be able to see it. The image that just got pushed. Come on. Okay, so this is the one that was pushed just a few seconds ago. Okay, Quarkus Cassandra. Of course, there's that was pushed 4 months ago. Not worry about that. This is the image that we're going to be using, to stand up the application. And here's the nice part about doing this is what it did was in addition to generating and pushing the Docker image, it also generated the manifest for me. Okay. So if I go back in here, okay, go back to my Explorer window. Actually, let me go here, view, Explorer window, right? And if I look at, what was I looking at? Target, right? And target Kubernetes is the word is? Yeah, Kubernetes. Okay, and Kubernetes.yaml. Okay, so it will show you here the Kubernetes YAML. Okay, so all of this is automatically done for me. You can see here it's Quarkus Cassandra, right? And then somewhere in here it should have my name also. Okay, Docker login ID or something like that. I don't know where the heck it is, but I'm sure it is. Kubernetes namespace. Okay. Should be in there somewhere. Oh, there it is, right? So essentially what it did was it used my login and it's going to stand up that image automatically from there, okay? So I don't really need to do anything, okay? So let me go back here. Now there are two options, Lens or OKTito. I'm just going to take OKTito for today, okay, because we did Lens last week. Okay, so I've downloaded the config file, I've created the cluster and all that. So let's see what happens, okay? I'm going to export kubeconfig, okay? And let's see what happens here. Okay, terminal. Okay, go back and take a look. And you can see that I don't really have anything. There are no resources running, right? Can you see that? Okay. So now what I need to do is I need to set up the secrets, right? Because that has to be done. And there may be easier ways of doing this, but essentially I create the secret and I get the secret and all that. So let me see if I've already set this up. Sometimes I might have done this, but never know. Okay, I think it's done, right? You can see the Astra username and the Astra password, right? It's all set up. So it's good to go. Now what I need to do is, I really don't need to do a whole lot. Push the image, okay? So to be able to push this, all that I need to do is do this, okay? Which is run the Quarkus command, okay? So I'm going to run this and push this, and you can see here deploy is also true, okay, which means it's going to deploy it to that particular cluster, okay? So hopefully this is going to deploy to the cluster, and if I go to OKTito, let's see, oktito.com. Okay, and I'm going to log in with GitHub. Come on. Okay, there you go. And here's my namespaces. And you'll see it's just starting off. Okay, the application just started off. Okay, so I'm able to containerize it, push it to Docker Hub, stand up the image from Docker Hub, all, the whole inner loop, pretty straightforward, right? So I pushed it, and now if I do a kubectl get all, right, I should get, a little bit more, right? So let's go back and look. This is with kubectl. If you don't want to use kubectl, you can use lens, doesn't matter. Okay, and you can see here the application is running. You see that? Okay, so it's running here. And there are two ways of accessing it. You can access it from OKTito, okay, or you can just set up this OKTito console. So all that I need to do is do this, right? And it should be good to go. Okay, and again, let me go back to this application and make sure that it's not running, right? Oh, it is running, because what happened? Oh, maybe it's already stood up, right? So the Kubernetes application is already running, and that's why it stood up, okay? So let me do this, which is delete the application and then show that it's really stood up by, so again, the delete is here. You can go ahead and delete everything, okay? I'll delete everything. Okay, you can see the deployment, everything is deleted, right? And now if I go back to this application, this should not be running, right? And it's still running. Okay. What am I missing here? Did I run my Docker and did I kill it? This is the magic. Let's see. Get all. Let's see this. Okay, there's nothing in the namespace. Oh, I know what might be happening. Debug. Debug might be causing something here. Okay. Let's see if I can get rid of this debug console. This is awkward. All right. Let me try this again. And I'm going to stop this. Okay. Okay. All right. Not quite sure why that's running. It's not supposed to be. Okay, there is. So here you can see that it's not running, right? And this is running. Quarkus Astra. Okay. Let me do this again. Okay. So curl. Back to my curl, right? Okay, so here's showing connection refused. I have no idea what's going on there, okay? Might be something to do with the browser. But now, let me push that image again and deploy the image, okay? So I'm deploying the image, and this should go and push to OKTito, okay? All right. And it deployed it into the namespace, and you can see if I get all, you will get everything. Okay. And now if I do the curl localhost 8080, it should hopefully work. Okay. As soon as it starts working. Okay. All right, now it's up and running, up and running, up and running. Okay. I really don't know what's going on here. 8080 should be, I got rid of Docker. There's something else that I'm missing here. But just follow the workshop and you should be able to, without taking any shortcuts that I did, right? And you should be able to get to that, okay? All right. So one last thing that I want to show, which is the coolest part of the application, is so let me what I'll do is I'll get rid of this whole thing. Okay, and I'm gonna start again and see what happens. I don't think it'll change anything, but never know. Okay. So this might be a good time for me to run the native image, but let me give it a second. All right. So to be able to generate the native image is very straightforward. All that I need to do is maven clean package and pnative and set up, skip the tests, right? So I'm going to run that. And this will take a little bit of time. Okay, probably a good 5 minutes or so. But eventually you should be able to get the native image, okay? Keeping fingers crossed again. And let's see if my application is still running. Oh, yeah, okay. Okay, this is running, okay. So you can see here it's using the Graal VM. Okay, it's doing a lot of what typically the Java VM would do at runtime is now being pushed to compile time. So it does, kind of, the reflection, class loading, all of those is done. As you can see here, it's parsing the methods, it's inlining the methods, it's compiling the methods to the native, format, right? And all of this is done automatically for you. It uses the reflection, does the JNI, whatever, magic it's supposed to do. As a developer, I don't need to worry about any of that, right? It happens automatically. It's finished up 6 of the 7 steps, and hopefully it's going to finish up pretty quickly now, right? Okay, there you go. And here's the beauty of this application is when you run this, you will see that it's going to run so much faster, okay? You can see it visibly, especially when you're running it yourself, okay? All that I need to do to run it is run the native image, right? And I'm gonna, this is the native image that's running right now, okay? So pretty cool. You saw that, it came up like really much quicker, okay? So let me run it again. And I don't really care. You'll see that it's already up and running. The image is up and running. As opposed to, if you were running it, taking a lot of the penalty at compile time. So if I run my, where's my, okay, GP. Let's bring one more. And let's try to run this outside. Okay, and this is the native image. So we saw all of this. We started off with, basically starting with QDev mode, right? And then we looked at debugging, and then we looked at containerizing it, with Docker and then with Kubernetes. And that's pretty much all that I wanted to do in today's workshop. So let me finish up by pointing you at some of the resources. Okay, again, if you want to take a note of this, okay, GitHub.com, DataStax Devs, workshops, intro. If you just go to DataStax Devs, you should be able to find it, okay? Just look for Quarkus. Okay, this is really about Quarkus and Cassandra. And I want to thank you all very much. Thanks for coming. I'll be around if you guys are working on it. Anybody got any of the exercises working? Few? How many? What exercise? Shout it out. 6, 7, 8, 9. Which one? 10? Oh, you got all of them done. Debugging also working? Yeah, you skipped debugging. Okay. So I was going to ask you for help. Okay. How about you guys? To Kubernetes? Okay. Okay. Oh, you don't have a Docker account. Okay. Then you can't do it. Yeah, exactly. But did you try the debugging, or did it work for you? Or no? Okay. Yeah, try it out later. That's an exercise for the reader, right? With that said, thank you all very much.